All right, welcome back. So in this part two of this kind of tangent into like roots and stuff like that, before we get back and kind of wrap up the entire polynomial section, today I want to talk to you about imaginary numbers. Beep, 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 beep. All right, so from last time, we figured out how to reduce the square root of 12. We do that by breaking it down into its factors, right? You want one of those factors to be a nice square root, right? So for instance, the square root of 4 is going to be 2 times the square root of 3. So this would be the simplified version of 12. Now, you've been taught in math classes before that, for instance, this scenario is not allowed. In fact, if you were to type in the square root of negative 12 onto a calculator, let me show you that. Square root of negative 12, the calculator would pretty much swear at you. They'd say like, no way, that's not possible. Can't square root negative numbers. But the thing is like, I feel like there is something I can do to it because, I mean, there is something I could do to the square root of 12, so there's got to be something I could do to the square root of negative 12. Like, for instance, what if I just, split this into this? I know that the square root of negative 1, right? Can't square root it, but I've broken this apart, so maybe I can just play with this part and, like, leave this part hanging, you know what I'm saying? So I could, multiply negative 1, and then I know that the square root of 12 ends up becoming something like 2 times 3, you know what I'm saying? So like maybe there is something I can do with it. And the answer to all of our problems is going to be this. The square root of negative 1, they came up with a definition for it. In fact, they gave it a placeholder. The square root of negative 1 in math can be written as a lowercase I, and the reason being is it stands for an imaginary number, which happens to be the first letter of imaginary. So when you are reducing square roots with negatives, breaking away a negative 1 and turning it into an I is actually favorable in upper level math. This is where imaginaries come from. It comes from negative roots. So for instance, this square root of negative 1 can technically just turn into an I. In fact, that is what you are supposed to do. So this would be the proper way of writing the square root of negative 12 in upper level math. Now, to be honest, I usually don't go up front. Usually what they'll do is they'll put the number first, then the I, then the root. But that's just being like overly like fancy schmancy. But this is technically the exact answer for the square root of negative 12. So let's take a look at a couple others. So square root of negative 25, for instance, could be broken down into the square root of negative 1 times the square root of 25. Well, what's the square root of 25? 5. And what's the square root of negative 1? Well, we can write it as an I, right? So 5i is just the square root of negative 25. In fact, any nice square root, for instance, I'll just do another one, square root of, I don't know, negative 36, is really just going to be the square root of that positive number, but just adding in an I. So negative 1, 36, the square root of 36 is 6 times the I, right? Because the square root of negative 1 is I. We can break these down a little bit more. So a couple more examples of this would be the square root of negative 1 times the square root of 50. Well, I know this is just going to give me I, right? And I know that the square root of 50 can be broken down into the square root of 25 times the square root of 2 from last time. So this ends up being square root of 25 is 5 times I times the square root of 2. So this would be the exact version of what the square root of negative 50 is. Let's try 18 real quick. So we'll start by breaking away the negative 1. That's going to turn into I, right? Square root of negative 1 is I. 18, let's see here, breaks down to square root of 9 times square root of 2. Square root of 9 is 3 times I times the square root of 2 would be the exact version of the square root of negative 18. So that's one way we can use i's, is just simply that. It's just what to do when you run into a negative square root. But there's more to it than that. For instance, what if I wanted to know, well, I know what I is, it's the square root of negative 1, but what is I squared or I cubed or I to the 4th? Is there anything I could do with I other than just playing it meaning the square root of negative 1? And, well, cool things happen. So let's let's take a look at that. So I squared, for instance, if I wanted to figure out what that is, I could technically replace I with what I is. I is the square root of negative 1. And if I square that square root, well, we know that when I square a square root, that's the inverse of it, right? So that would just end up being, well, negative 1. So, for instance, I squared, that's just equal to negative 1, which is, again, kind of weird, but it is what it is. What's I cubed, for instance? So I cubed would be, let's see here, the same as, I don't know, I times I squared, right? Because that would be I times another I. And, well, we know what I squared is. It's negative 1, right? So I times I squared would be the same as I times negative 1, which would equal negative I. So I cubed is negative I. Kind of weird, but cool. And then I to the fourth, we could think of that as, I don't know, I squared times I squared, because that would be, you know, like two i's times another two i's would be, you know, four i's strung together. And, well, we know that I squared is negative 1, and we know that I squared again is negative 1. So negative 1 times negative 1 is 1. So we got this weird thing going on that, for instance, I squared is negative 1. We know I cubed is negative I to the fourth is 1. If I were to keep going, for instance, I to the fifth, I to the fifth would be the same as I times I to the fourth. I to the fourth is 1, right? So I times 1 equals I. Weird, huh? So there's this other cool trick with imaginary numbers that looks something like this. If I is equal to I squared is equal to negative 1, I cubed is equal to negative I to the fourth is equal to 1, I to the fifth is equal to I. And if you take a look at it, there is a pattern going on, because if I continue, I'm going to end up keep alternating between I's, 1's, I's, 1's, I's, 1's, and the fact that there's definitely a pattern going on here, and I can go on forever and ever. That's why if you look up imaginary patterns or imaginary numbers online, you're going to see this pattern a lot. And there's some cool tricks you can do with this, like, for instance, figure out, like, what is I to the 253rd power, and then it's going to be one of either I negative 1, negative I, or 1. So there's some cool stuff you can do with that. You'll play around with that more in upper level math. But for now, let us kind of finish up. So with that being said, last but not least, sorry about that, I would just like to play with I's a little bit more. So today's assignment is just going to be getting used to just doing operations with imaginary numbers. So pretty much what you've been doing with, algebra, except, I's are a little bit different because when you square them or cube them, they kind of morph into different things. So let us begin. So for this particular one, I just want to add things together. These work the same way as variables. So for instance, 3i minus 2i is just 1i. And if I add these like terms, I would get 11. So that would be the simplified version of that original problem. Let's try a problem like this. If I were to give you 2i minus 4 times 3i plus 5, this just looks like a foiling problem, right? So I would multiply this times this. That would give me, 6i squared. I would multiply that times that, and that would give me, 10i. I would multiply negative 4 times 3, and that would be negative 12i. And then last but not least, I'd multiply negative 4 times 5. And that would be negative 20. I could do some simplifying here. For instance, I squared, we just learned that I squared is equal to negative 1. So I could turn that into a negative 1. I can add these guys together. 10 minus 12 is negative 2i minus 20. And 6 times negative 1 is negative 6. And then I can combine negative 6 with negative 20. So that would become negative 26 and negative 2i. So that would be the simplified version of that multiplication problem. Let's try one more. there we go. 4i plus 3 squared. So if I'm going to square this, remember you're not distributing the square. What you're going to do is write 2 more of these. And we're going to FOIL it. So let's go ahead and do that. 4i times 4i, that's going to be 16i squared. 4i times 3 is going to be 12i. 3 times 4 is going to be another 12i. And then 3 times 3, that's going to be a positive 9. Again, I can combine these like terms. That's going to be 24i. But remember that I squared or I cubes or I to the fourth, they are equal to other things. So I can simplify this a little bit. For instance, that would be the same thing as 16 times negative 1 because I squared is negative 1. So 16 times negative 1 is negative 16 plus 24i plus 9. And then if I add the negative 16 and the 9, I would end up getting, let's see here, what, negative 7? And that would be my final answer for that. So this is just a really quick, honestly, quick run through of imaginary numbers. And today's worksheet, like I said, will be more problems like this just to get you familiar with imaginary numbers in whole. We'll come back to their uses of the polynomials next time. So what I would like you to probably jot down in your notes is this conversion thing. So I is equal to I, right? I squared is equal to negative 1. I cubed is equal to negative I. And then lastly, I to the fourth is equal to positive 1. If you go further than that, I'm sure you can figure it out because it just continues this pattern forever and ever on down the line. But this is going to be helpful for doing problems like this when you're doing operations with imaginary numbers, okay? If you have any other questions, office hours are from 1 to 2. If not, you guys have a wonderful day. Talk to you later. Bye.